1 of how to subnet an IP version 4 network. So the easiest way of doing it is to keep the octet boundaries. And this is also when we, for instance, calculate, or we have seen that before, when we have calculated and find the network address and the broadcast address when we have an IP address and a subnet mask, we will see that it's, as long as it is something with /8, /16, /24, it is very, very easy for us to calculate. We don't have to do the binary math to find out what is the network address and what is the broadcast address. And the same thing applies when it comes to subnetting, because the whole idea of subnetting is to borrow some bits. And what we do is that we borrow bits from the host part of the network or of the IP address and give them to the network, which creates more network with fewer hosts. And if we do that, for instance, if I have an IP address with a /8 or let's say /16 subnet mask, and then I can create 256 new networks by making the subnet mask 200 or /24 instead, because what I actually do then is I borrow 8 bits and create 256 new networks. I don't have to think about how it's done and how to do it when I have 8, 16 and 24 as my subnet mask, because then I will just know how the networks are divided. So for instance, if I have 10 something 00/16 and I borrow the 8 bits so that my new mask is /24, well, then I will create 256 new networks, because I will have 10 something 00/24, 10 something 1/24, and so on. 1, 2, 3, 4, 5, 6. This number here will change, because now instead of having just 2 parts of the IP address that describes the network, like I have up here with a /16, well then now I will have the first 3 parts that will describe the network. So it's very easy to do it on the octet boundaries. But what we are doing when we have classless subnetting is that we borrow bits from the host part to the network part. And if I have a /24 address and I borrow 1 bit, my new mask will be /25. Borrowing 1 bit will give me 2 new subnets, and with each 126 hosts each. And I get 2 new subnets because I borrow 1 bit. Borrowing 2 bits will give me 4 new subnets with the room for 62 hosts. Borrowing 3 bits will create 8 new subnets and support 30 new hosts. 4 bits will create 60 new subnets with 14 hosts. 5, 32 new subnets with 6 new hosts each. And borrowing 6 bits will give me 64 new networks with the room for 2 hosts, so that we can see the number of hosts decreases, the number of network increases when I borrow more and more bits. For instance, this is why. Now I'll just take the simple one. The one when I have 192.168.10/24. That is my original network. Now I borrow 1 bit, so my new network address or the subnet mask will be /25. So what I do is that I borrow the first bit in my host portion of the IP address. So now this bit here, the red one, will now be a networking bit instead of a host bit like it had been originally. So this network bit now can have 2 values. That is why, since we borrow 1 bit, it could either be 0 or it can be 1. And my new mask will now be 255, 255, 255, and then a 1. This is only the binary portion here. This is, of course, 8 ones, 8 ones, 8 ones, and 1, and then 0, 0, 0, 0, 0. So this is /25. So my two new networks, if I calculate them back to decimal numbers, well, then I will see that my first network will be called 192.168.1.0 because 0, this is now the networking bit, but still 8 zeros is 0, so that is the first network address. And the second, the last one, will be 192.168.128 because now the networking bit now is 1 and then followed by 7 zeros. So these are the addresses of my two new subnets. These are the network addresses of my two new subnets. And the mask will be 255, 255, 255, 128 because this one here now is 128. So now, instead of having one large subnet, I will have two subnets, which I can place on each side of my network interfaces on the router, for instance, because they will be two different separated networks. So the network address now is, as I said, 192.168.1.0. The first address is 192.168.1.1. The last one is 192.168.1.126. And the broadcast is 192.168.1.127. Again, I find the broadcast by setting all my host bits to 1 and keeping all my networking bits unchanged. The second network will be called 192.168.1.128. This is the network address, not the a host address. And the first host is then 192.168.1.129, and the last one is 192.168.1.154. And my broadcast on this network will be 192.168.1.255. Again, same thing applies here. To find my broadcast, I set all my host bits to 1. So then I can create a network on each side and on each interface here on my router, and I can give, for instance, the router interface the first valid IP address in each segment, 1 here and 129 here on router G01, for instance. And then, of course, also I give my computers also an IP address in each range. And the subnet mask is, of course, extremely important. Also, it's important that I have the same subnet mask on all of my devices in the same network. Cannot have different masks within the same network. When I calculate, as I said, I borrow a bit from the host portion to the network portion. And depending on how many bits, that is how I decide how many networks I will get. Because the formula is like this, 2 in the power of n, where n is the bits borrowed. So borrow 1 bit gives me 2 networks, borrow 2 bits gives me 4, because 2 in the power of 2 is 4. 3 bits gives me 8 new networks, 2 in the power of 3 is 8, 2 in the power of 4 is 16 when I borrow 4 bits, 5 bits I get 32 new networks, and 64 new networks when I borrow 6 bits, for instance. The important thing is to remember that I have to keep at least 2 bits left for the host. So my highest subnet mask can be /30, because then I only have 2 bits or 2 bits left for the host, and that is how I calculate the number of hosts that I have in each network. I take 2 in the power of n, where n now is the number of bits remaining in the host part of the IP address, and then minus 2, because the first host address is used for the network and the last one is used for the broadcast. So that is why I always have to subtract 2 when I calculate the number of hosts. So in this case here, where I have 7 hosts remaining, because I had originally 8 host bits, I borrowed 1, so now that gives me 7 bits remaining for the host. So I have 2 in the power of 7, which is 128, minus 2. which is 126 valid host addresses in each subnet. Yeah. So then I can also do the same thing when I, for instance, borrow 2 bits. That will create 4 new networks. And now my networking address is /26. If I have the same address 192.168.1.0 in the beginning with a /24 address, borrow 2 bits gives me /26 in the new one, and then gives me 4 new networks. So that gives me now again the 2 red ones here are now bits that goes from being host bits to being networking bits. And these 2 bits can have 4 different values: 0, 0, 0, 1, 1, 0, and 1, 1. And when I calculate these backwards, I will see that these are now my new 4 network addresses. So it's 192.168.1.0/26, 192.168.1.64. This one here is 64/26, 192.168.1.128/26, and 192.168.1.192/26. So these are now my new 4 networks when I borrow 2 bits. And my new mask will be, and this will apply for all my networks here, is 255, 255, and then borrow these 2, and followed by 6 zeros is 192. So 255, 255, 255, 192 is now my new mask. Yeah. And then the same thing to find the first and the last host again. If my network is 0, my first host address is 1. The last host is the broadcast -1, so it's 62. The broadcast I will find by keeping all my networking bits unchanged and then putting in all 1s in the host portion of the IP address. Yeah, so then again, now I get 4 new networks, and this is just to give you the overall idea of the first and last and broadcast on each and every one of these 4 networks. And then we can use, in this case here, I only have 3 interfaces, so I will keep them on my local router here and give them each one separate subnet on each and every one of them.